All right, checkpoint 2.4, number 2. First thing we're going to do is put our name on this always. And so I'm going to write my name on here. My name today is going to be J Bob. Last name, always too, Kelly. Okay. So I know a lot of you are probably jealous, but you can name your kids J Bob someday. Write an equation of a line parallel to y equals 3x plus 6 through this point and graph both of the lines. All right. Well, what do we know about parallel lines? Yes, you're right. You're totally right. They have the same slope. Good. So they have the same exact slope. So here we go. Well, let's see. If I want a line parallel to 3x plus 6, y equals 3x plus 6, that's going to be 3x plus something else. I don't know what this something is yet. I got to figure that out yet. How do I figure out that bubble? Really, we kind of call that bubble a B in the business, in the math biz. All right, but what is in that bubble there? Well, if only I could plug in some point or value for x and y, because there's just so many oh yeah, I can plug in this point right here, see? Because I know this point's on that line. So it's parallel to that line through this point. So I can put y in, or y, 1. They both start with the y and 1. I can put 1 in for x, and then I can also put 6 in for, yeah, you got it, y. Good. And then I'll find my my missing bubble, or b, which stands for bubble. B stands for bubble. 1 in for x. Boom. Do that in green. Keep the colors. 1 in for x. Yes. 6 in for y. Perfect. Okay. Now, when does 6 equal 3 plus what number? 6 equals 3 plus bubble. You could figure that out. That's like a little elementary school question. That's kind of a fun little thing when you're practicing your addition. 3 plus what is 6? Oh, 3. Great. Okay, so 3. So that one's going to be 3x plus 3. Let's graph these two puppies now. So now we go down to 6. So we go 1, 2, 3, 4, 5, 6. We go down or up to 6. And then it has a slope of 3, so it's going to go like this. Boom. And then since these are going to be parallel, I'm going to try to do a really good job of keeping these things going. There we go. All right, and then let's do, let's do the other one in purple. Purple. 3x plus 3, that's going to go up 3. So it's going to go right up to here. Whoa, they're really close, but they're never going to touch. Yep, never going to touch. How neat is that? Okay, so if I try to draw my lines through there, let's see. Slow. Ooh. Okay, and then my black line go through there. Come on. Ooh, nice. See how they're parallel? Why are they parallel? Same exact slope. Same exact slope. All right, next question. Instead of parallel, we have is perpendicular. So if they're perpendicular, let's see here. If they're perpendicular, how does their slope relate? Okay, so if they're perpendicular, how does their slope relate if two lines are perpendicular? Yeah, Ricky? Yeah, you're right. They are. Oh, wait a minute. What'd you say? They're reciprocal. Close. They're reciprocal and yeah, Susie. Yep. Yes, they're opposite and reciprocal. Great. Okay, so they're opposite, which means if you want perpendicular to -2, it's going to be positive 2, and then their reciprocal to that is 1 over 2. So we're talking about y equals positive 1/2 x plus the bubble. Remember bubble stands for, right? B. So, if there's only one way I could plug something in for x and y. Oh, yeah, that's right, the point. Silly. So put the point in. So put, let's see, I use green for x, so we go 6. We put that in for x. Great. And then we put 4 in for y. You substitute those in. Okay, substitute. Use parentheses. I think that's a good common practice. In this case, when it's all lone y, it really doesn't matter. So it's like 4 equals, and then we got 1/2, and now if I use parentheses, it's going to mean times, right? 1/2 times 6 plus the bubble. All right, well, that's going to be 4 is equal to 3 plus the bubble. Well, what's the bubble going to be there? Hey, that's going to be 1. Great. All right, so now the bubble is 1. So now I have 1/2 x plus 1. So let's graph both those lines. Okay, let's graph the first one in black. Let's go negative 2x plus 4. So I go up to 4. There it is right there. And then I go down to, rise over run. I go down 1 for every 2 I go over. So I'm like, no, I'm making a mistake. Okay, slow it down, deep breath. Listen for the deep breath. Okay, good. Now we got negative 2 as our slope for this one. So every 1 I go over, I go down 2. There we go. And I'll just be very diligent about just extending these little fun little dots, these little stairs all the way. Good. And now I'll do the other one in purple, and that will be a positive 1/2 x plus 1, so that's going to go through right there, and it's going to go up 1 for every 2 it goes over like that, and these two lines should meet and intersect at 90 degrees. That's what perpendicular is, 90-degree intersection. So how does it look? How do they look? How did we do? Do they look like they intersect at 90 degrees? Pretty good, huh? Pretty good, not too bad. There you go. That's perpendicular lines. Opposite reciprocal slopes, parallel lines, have the same slopes. All right, thanks for watching.